Let's look at few more types of transformation. Now this time it is y equals fx minus d. In this situation what happens is, in this kind of transformation what happens is, the curve will go down along the y-axis. If you look at an example, if you consider the function fx equals a to the power x, this is an exponential function. If you look at the graph of this, it will look like this. This is the graph of f equals a to the power x. When x takes negative infinity, this will go to 0. When x is equal to 0, this is 1. When x takes positive infinity, it will go to infinity like this. This is the graph. And this x-axis will act as an asymptote. The x-axis will act as an asymptote. Now, we will look at few transformations of this type for this function. Let's look at this fx minus 1. Fx minus 1, that means a to the power x minus 1. So this graph will move down by 1 point. So this 1 will come and stop at 0, and then asymptote y equals 0 line, the x-axis will move to, for this graph, my new asymptote will be y equals minus 1. Right, let's look at it. This is the asymptote, new asymptote. Look at the way it is moving. It moves down by 1 point, and this came and sit here. Okay, we'll look at a similar example. Fx minus 2. This is yet another transformation of this one. So what happens is, a to the power x is the basic graph. Fx minus 2 means a to the power x minus 2. This original graph will be moving down by how many points? Right? Moving down by 2 points. Now this 1 will come and stop at minus 1. 0 will go to where? Yes, 0 will go to minus 2. Right? Because it is moving down by how many points? 2 points. So our new asymptote will be what? Yes, it is minus 2. Right? We will first draw the new asymptote minus 2 like this, and then we will draw this curve. Right? This will come up to minus 1, and then it will go like this. Let's see. Right? Now we will look at another example. This is a very easy thing to understand. It's not complicated at all. Right? Always this basic graph is moving down by the particular number of points here. Right? Now we have a function y equals minus x squared. You know the graph of this, right? This is a very easy thing, simple thing. The graph is like this. It's a maximum curve, right? It's a maximum curve. Now we will look at some transformation of this basic curve, right? What is this? fx minus 1. Fx minus 1 means minus x squared minus 1, minus x squared minus 1. So this basic curve will be moving down by how many points? 1 point. So this 0 will come and sit at minus 1. Look at this. This is the transformation which occurs here, right? We will look at another example. See, fx minus 2. What happens here? Now it is very obvious for you. This basic curve, this one, will be moving down by how many points? Will be moving down by 2 points. So this 0 will come and sit at minus 2. So it's a very easy transformation to study. This is the transformation which occurs at this place for this, right? We will look for some more examples. Look at this one. If our function is fx equals x squared, so this is the opposite side of this one. Now this is a maximum curve, and then for this one it will be a minimum curve, right? Smiley face and the angry face. Okay, look at this. This is the basic graph of this, and then we will look at some transformation of this. Fx minus 1, right? See, x squared minus 1. So what happens here is this graph will move down by 1 point. This 0 will come and sit here. Okay, look at this. Now of course a beautiful pattern coming up, right? So that is mathematics. Mathematics is always beautiful, isn't it? Right, look at this. Another transformation, fx minus 2. So now it is pretty obvious for you. You can see what it is. It will directly come and sit here. Wow, see how beautiful it is. If you can actually continue this a little more, it will be very beautiful, right? Okay, right, we will look at another example. This time a trigonometric function, fx equals cos x. Cos x is what kind of a curve? It is starting from 1 and then go like this. Look at this. Right, now we will look at few transformations of this. Look at this, fx minus 2. This time what happens? Will go down by how many points? This graph will go down by 2 points. Then this 1 will come and sit at minus 1. Look at this. Right, okay, we will look at another example, fx minus 3. Fx minus 3 means this graph, the original one, will move down by how many points? 3 points. Then this 1 will come and sit here, minus 2. Look at this. I think now you could understand really well this transformation. Here also it is very beautiful. If you have another curve here, fx minus 1 also, and minus 4 and so on, then it will be a very beautiful pattern, right? Okay, we will move on and see. We will look at this now. Fx equals sin x. Fx equals sin x is this curve, right? Then fx minus 1 means this original curve moves down by how many points? 1 point. Then this 0 will come and sit where? At minus 1. Look at this. We will look at another. Right. I think that is enough for this kind of transformation. We will have a look at another kind of transformation. Right. Fx equals x minus 4, x minus x plus 4. So this is a cubic curve, and it's a beautiful curve like this. We will look at it. Right. Now we will look at a different transformation of this, that is f2x. All the x's are multiplied by 2. f2x. Each and every x here is multiplied by 2x by 2. Then this will become 2x. This also will become 2x. This also will become 2x. Right? If you try to look at this new graph, then all the x coordinates will be divided by 2. Look at this. When this becomes 0, right? 2x minus 4 is equal to 0. 2x equals 4, then x equals to 2. This is 2x plus 4 equals 0, 2x equals minus 4, x is equal to minus 2. So it will be here and here. 0 is itself. 0 divided by 2 is 0 itself. So you will have your new curve like this. Right? Now look at this. Y coordinates are intact. Only x coordinates are divided by 2. This minus 4 became minus 2. 0 divided by 2 is 0 itself. Plus 4 became plus 2. Right? We will look at another example of this, another transformation of the same type. Right? Now this is f4x. Right? f4x means what? Each and every x in this original will be multiplied by 4. So f4x, this will be 4x, this will be 4x minus 4, this will be 4x plus 4. Right? So what happens here is, each and every in the new graph, these x coordinates will be divided by 4. So this minus 4 is divided by 4, then it will become minus 1. This plus 4 is divided by 4, it will become plus 1. 0 is divided by 0, it is 0 itself. Then our new graph will be this. Look at this. Right? Okay. Here also the y coordinates are intact. Y coordinates are same. Right. We'll move on and see another example. Look at this. Fx equals x squared. Right? This is a simple graph. You know that. Fx equals x squared. Right? When x equals 1, y equals 1. When x equals 2, y equals 4, 3, 9, 4, 16. Same way here, right? We will look at a transformation of this one. What is the transformation? Here you have f2x. f2x means this x is replaced by 2, right? This x is replaced by 2, that means it will become 4x squared. When you look at the graph of that, it will look like this, right? When x equals 2, only this is 16, so this x coordinate is divided by 2. 4 divided by 2 is 2, minus 4 divided by 2 is minus 2, right? So this 16 occurs for this curve. 16 occurred at x equals 4, but for this curve 16 occurs at x equals. Look at another transformation of this. If you have f4x here, then it will be 4x whole thing squared. So what will happen? All these x coordinates will be divided by 4. So when you divide this one by 4, it will become 1. When you divide this one by 4, it will become minus 4. So 1, 16, minus 1, 16. Look at this. This is the curve, right? Now for this original one, when x equals 1, it is 1, right? For this one, x equals 1, it will be 4. For this one, so it goes like that. Now we will look at this sin x. Gx equals sin x. It is a curve like this, right? Now we will look at this g2x. That means sin 2x. What will happen is all the x coordinates will be divided by 2. That means this full graph occurs when x equals 180 here. There will be actually 2 graphs here. Look at this. So what happened at x equals 180 will occur at 90. What happens at x equals 180 will occur at 90, right? What happened at x equals 180 will occur at 180, and then this curve is repeated back again. We will look at another transformation of this g3x. That means sine of 3x. That means this original curve will be repeated 3 times. Here it is 2 times. For this new case it is 3 times, right? Then what happened at 180 will occur at 60, right? But when you divide this one by 3, it is 60, right? What happened at 360 will occur at how much? 120. Okay, so this curve will be shrink to this and then repeats 3 times. Look at this. Right, so this is the, so y coordinates are intact, only the x coordinates are shrunk. Okay, right. This is a y equals x, or fx equals x, right? And then when you look at f2x, it is 2x. then it will be moving like this. Get this. Then f3x, it will further move to this side. All the x coordinates are divided by 3. So I think you got the understanding of this kind of transformation now. Fax is the kind of transformation. Children, I think you enjoyed this video, and please like this video and subscribe my channel so that I can give you more and more beautiful videos like this. Thank you.